All right, let's just jump right in. You know that feeling, right? You ask the same question to GPT, Claude, and Llama, and you get 3, maybe 4 different answers. Now, they're all pretty good, none of them are wrong, but they're all just a little bit different. It feels kind of chaotic. But what if that chaos isn't chaos at all? What if it's actually a map in disguise? And this, of course, leads everyone, from developers all the way up to the C-suite, to ask what feels like the most obvious question in the world: which AI model is the best one? It's the question we all start with. But it turns out, it's completely the wrong way to think about it. Because here's the secret. Those differences you're seeing, they aren't random. They're not bugs or noise. They are, in fact, intentional design choices. They're choices that reveal different priorities, different trade-offs, and a hidden market structure that today we are going to map out together. And the best part? This entire seemingly insane market can be understood with a super simple 2-dimensional map. It's a framework that just cuts right through all the noise and shows you exactly where every single model fits into the bigger picture. Okay, so dimension number 1 is a big one: closed versus open weight. On one side, you've got your closed models. Think GPT, Claude, Gemini. You access them through an API, which is kind of like renting their power. You pay per use, but they control everything. On the other side, you have the open weight models, like Llama or Mistral. Here, you literally download the model files and run them on your own servers. You have total control, but you also have total responsibility. Now for our second dimension, frontier versus commodity. Frontier models are the Ferraris of the AI world. They're the biggest, the most powerful, and yeah, the most expensive. They're built to push the absolute limits of what's possible. Then you have the commodity models. These are the reliable workhorses. Think of them as the Toyota Camrys. They're smaller, faster, way cheaper, and they're designed to do proven tasks really, really well and at a massive scale. And when you cross these two axes, closed versus open, and frontier versus commodity, you get this: a beautiful 2x2 grid. This is our map. 4 distinct quadrants, each with its own rules, its own use cases, and its own set of risks. So let's take a little tour of the neighborhood, shall we? Every AI model you've ever heard of lives in one of these 4 quadrants, and knowing where they live is the absolute key to choosing the right tool for the right job. First up, in the top right, we have the flagships. Think of the biggest and baddest models out there. This is the quadrant you turn to when capability is everything and cost is a secondary concern. We're talking about incredibly complex reasoning, novel analysis that's never been done before, or building those sophisticated AI agents that can handle multi-step tasks all by themselves. You pay a premium, for sure, but you're getting the absolute best the market can offer. Okay, next up, the workhorses. These are the fast, cheap, and surprisingly good models that honestly handle the vast majority of real-world AI work. Things like classification, pulling specific data out of a document, routing requests, summarizing text. Most of the AI that's baked into products you use every single day is being powered by a model from right here in this quadrant. Now, let's move over to the left side of our map, the self-hosted powerhouses. This is for when you need that top-tier, frontier-level quality, but it has to run on your own servers. Why? Maybe for data sovereignty. Your sensitive data can never leave your site. Or maybe you're running such a massive volume of requests that it's cheaper to own than to rent. The catch? You're paying for it with some serious GPU hardware and a whole lot of operational complexity. And our final quadrant is home to the edge specialists. These are the small, lean, super efficient models that can run on your phone, in your car, or on other pretty modest hardware. They're perfect for on-device AI, tasks that need to be lightning fast, or for those jobs where a small model, fine-tuned to do just one thing perfectly, can actually blow a giant general-purpose model out of the water. Okay, so we have our map, we know the lay of the land, but how do you actually use it to navigate? This is where we shift from just understanding the market to actually making smart decisions. We need to forget which model is best and adopt a much more practical framework. And here it is. It's a simple 4-step sequence. First, you start with your constraints. Second, you look at the stakes of the task at hand. Third, you have to test for the actual fit. And fourth, you always have to think about vendor lock-in. Step 1 is honestly the most important. You start with what you can't do. Are there regulations that say your data can't leave your private network? Boom. Just like that, the entire right side of the map is gone for you. You're limited to open weight models. Have a super strict latency requirement? That might rule out those slower flagship models. Constraints can wipe entire quadrants off your map before you even begin. Next up, you ask, what are the stakes? If a mistake is no big deal, like, say, miscategorizing an internal support ticket, use the cheapest, fastest commodity model you can find. Those savings really add up. But if it's a high-stakes task, like generating a legal analysis for a client, you start with a frontier model, and you probably have a human in the loop. It's all about matching the model's power to the task's risk. Now, this part is absolutely crucial. You have to test for your specific needs. Forget the public leaderboards. I mean, they're interesting, but they don't reflect your reality. The only benchmark that truly matters is how a model performs on a dozen real-world examples from your workload. You need to build your own private test suite. That's how you find your true winner. So let's zoom out for a second and take the strategic view. Because once you start thinking in these quadrants, you quickly realize something. Any serious production-grade AI system is probably not going to rely on a single model. The future is multimodal by default. And this is what that looks like in the real world. You might build a smart router that sends easy tasks to a cheap commodity model, but sends the really hard ones to an expensive frontier model. Or you could build an ensemble, where you have a few different models tackle a problem, and then a fourth model judges their answers to pick the best one. You can even build an agent loop that uses a big model for planning and smaller models for execution. And why on earth would you go to all this trouble? Well, this number is why. A smart router can often save you 70 to 90% on your inference costs. That's the cost of actually running the models, compared to just blindly sending every single request to a big, expensive flagship model. That's not just a small optimization, that is a game-changing amount of money. You know, relying on a single provider also opens you up to all kinds of risks. Prices can change overnight. A use case that works today could be forbidden by a new policy tomorrow. The model you built your entire product on could just get deprecated. And, of course, outages happen. Now, this isn't a reason to avoid these providers, but it's a huge flashing neon sign telling you to design for portability. This all leads to a really fundamental shift in mindset. The old way of thinking was, we're standardizing on Model X. The new way, the smart way, is to say we're standardizing on an architecture that can use Model X, but can also swap in Model Y or route to Model Z. It's a subtle change in how you talk about it, but it creates radical flexibility down the road. At the end of the day, the AI model market is starting to look an awful lot like the cloud computing market did back in, say, 2015. You've got a few giants, you've got a growing ecosystem of specialized players, and the smartest companies are not betting the farm on a single winner. They're building for a multi-cloud, multi-provider world from day one. It's the best analogy we have, so, plan accordingly. Which really leaves us with one final critical question you need to ask yourself as you build out your own AI strategy. When you commit to a single model from a single provider without an exit plan, are you really just buying a tool? Or are you buying a dependency that's going to be very, very difficult to escape from later on?